chapter 12, the new unit on trigonometry. So we're going to talk about, right triangles and some special trig functions. So we're going to find out how to find the missing side of a right triangle using some special trig ratios that we'll discuss. And also we'll talk about special right triangles. We'll also focus on finding a missing angle using these special trig ratios. So those are the goals. So let's start talking about what trigonometry is. So like I said, this unit focuses on trigonometry, which is the branch of math that deals with sides and angles of triangles. So there are three special trig functions that we'll look at in this lesson. And we'll focus mostly on these throughout the unit. So we have sine, cosine, and tangent. These three functions can be looked at as ratios. So we can think of them as ratios. So I'll show you, I'll draw a picture of a right triangle so you know how it looks like. So this symbol that you see here, so the shorthand for sine is SIN. Okay, so this is for the shortcut for sine, and this symbol that you see here, right here, that stands for the angle, and that's a symbol of that's called theta. So that's the Greek letter theta. Okay, so that's how you read that. So this is sine of theta. So you have to have an angle in front of the trig function that you're looking at. So this is sine of theta, second one is cosine of theta, third one is tangent of theta. So let's say that our angle that we're interested in is this angle here. Okay, we're going to call that angle theta. Then the sine is the opposite over hypotenuse. Remember that in a right triangle you have your legs and then you have your hypotenuse, right? So this right here is your hypotenuse. So opposite over hypotenuse, or O over H. And then cosine is adjacent over hypotenuse, or A over H. And tangent is opposite over adjacent, or O over A. Okay, so what does that mean? Well, in terms of this picture here, so this is your H. I'll just call this H so that you can see. So that's your H, or hypotenuse. And the side that is opposite this angle is, this side, the one that's directly across or opposite. So that's opposite. The side that is adjacent is a side that is next to the angle, which is, so that's A. Okay, so if you were to find sine, you would just do the length of this side, the opposite side, divided by the length of the hypotenuse, H. Okay, so that's how you use that in the right triangle. So a way to remember this is to use what we call SOHCAHTOA, where sine is OH, so the SO is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. So that's a way to remember. So when you do this practically and you're trying to find the missing side, you're going to make sure that your calculator is in degree mode. Alright, so on the calculator, so these are where the sine, cosine, and tangent keys are located on the calculator, the ones that we'll use in class. And there's a degree mode, so there should be a mode right here. So I think this is the mode key that we're going to look at, that we'll talk about in class when I show you the calculation. But I believe that's your mode change. Okay, so I'll play around with it when we get in class. All right. Start at the angle that is given, and determine from that angle which two sides you have. So basically, figure out, start at the angle that's given, and then determine, whether to use sine, cosine, or tangent, depending on which sides you have. All right, so let's look at it. So here we have a right triangle. Remember, these sine, cosine, and tangent are only for right triangles because they involve hypotenuse. All right, so remember the hypotenuse is the longest side on a right triangle. All right, so here you want to find x. So in this example, you're given that it's a right triangle. You're given this angle. So you're given the angle is 32 degrees, right? So that's this angle here. And you're given the opposite side, right? So this is like your O, basically. And then this is like your H, your hypotenuse, right? So you have sine of 32 degrees. Okay, and I'll write it over here. So you have sine of 32 degrees is equal to opposite over hypotenuse. So opposite is x, hypotenuse is 19. All right, then you want to solve for x, so you're going to times 19 on both sides to cancel. All right, so you're literally going to type in 19 sine parentheses 32 degrees on the calculator, and then you'll get that answer. So let me just do it on the computer here, but so you can kind of see the idea. All scientific calculators have the sine function. So 19 sine, and this calculator is a little different. So so in this case, we're going to do the sine of 32. Let me make sure something here. Yeah. So sine of 32 times 19. So we got about 10.07. All right. All right, so we got 10.0, let me double check again, 10.07. All right, so all right, and that's our side. So let's look at the next one. So here we have the angle is 50 degrees. Looks like we have the adjacent side, the side that is next to it, and we have the hypotenuse, right? So we're going to be using the cosine, so we need cosine, which is adjacent over hypotenuse. So we have cosine of 50 degrees equals adjacent, which is x, over hypotenuse, which is 35. So it looks like we got to times 35 on both sides to solve, and then that's x. Okay, so then we'll plug that into the calculator. Times 35, so 22.5, we'll round it. So x is about 22.5. All right. So now for part C, we have the angle is 21 degrees. We have the adjacent side, so we have A, and we have the opposite side, so we have O. All right. So when we say adjacent, we only say the adjacent side is the short side. We don't say that the adjacent side is the hypotenuse, okay? Because the hypotenuse has its own designation, okay? So this is adjacent, not hypotenuse, for x. All right, so we're going to be using tangent, TOA, right? Tangent is opposite over adjacent. So tangent of 21 degrees equals O, 11, over adjacent, which is x. So to solve for x here, I'm going to times x on both sides. So I now have x tangent of 21 equals 11, then divide off the tangent so I can solve for x. Alright. You can also think of this as cross multiplication and solve it that way. Yeah, so you can also think of it as cross multiplication and you'll get the same result. So either way, we got 11 divided by tangent of 21. So we got to do that on the calculator. So 11 divided by tangent of 21. So 0.384. Alright, there you go. So x is pretty short. Now if you think about it, if you try this out again, right, if you did 11 divided by 0.384, you would get tangent. So 11 divided by 0.384, that gives you 28.6. Let's double check that. Alright, so let me double check the number. So 11 divided by tangent 21, because that seems very small. Okay, there you go. So that's the number. Sorry about that. So 11 divided by tangent 21 is 28.66. So let's change that number. So about 28.66. So let me erase this. Okay, that makes more sense, considering that that's 11 and that's, so then this is a longer side. Okay, it makes sense that this side is longer just based off of the triangle. So that makes sense. Alright, so now you can also use SOHCAHTOA to find the measure of an angle. So if you wanted to find out what this, this angle is, the 21 degrees, if you wanted to figure out what that is, you can actually use it. So to do this, you must use the inverse of the sine, cosine, and tangent. Okay, because remember, normally with the sine, cosine, and tangent, you're putting cosine of some kind of angle, right? Goes in here. But you can figure out what this angle is by doing an inverse cosine, for example, to cancel this out. So that cancels and it gives you the angle. Alright? Again, the inverse cosine keys are located, so they're just above the sine, cosine, and tangent keys. They're written in blue. Okay, so here they're in blue. I don't know if you can see that, but they're in blue here, here, and there. So those are the inverse tangent keys. So you got to go hit, you got to hit second and then the sine, cosine keys. All right. So to find the angle measure in each triangle, so let's look at this one. So first you got to figure out which trig function you want to use. So this is my angle. We call that x. We know that that's opposite. So that's O. And this is hypotenuse. So that's H. So that's going to be a sine. Sine is opposite or hypotenuse. So SOHCAHTOA. So we got sine of x, because that's my angle. My angle is x, equals opposite over hypotenuse. So now to get rid of the sine, we introduce the inverse sine. The inverse sine cancels out with the regular sine, because remember, inverses cancel out. Inverses are opposites. So we have x equals inverse sine of 8 over 12. And then we can plug that in the calculator. All right. Okay, so I have the inverse sine now. So I want 8 over 12. And then I'll do the inverse sine of that. Okay, so that's 41.8 degrees. So x is approximately 41.8 degrees. Alright, let's try this one. So this one you have the angle is x, you have opposite, directly opposite, and then you have adjacent. Okay, so that's A. So over A, so that's cosine, or I'm sorry, that's opposite of or adjacent is tangent, TOA. So we have tangent of x equals 32 over 40. To get rid of the tangent, I got to do the tangent inverse on both sides. Tangent inverse. So that gives me x equals tangent inverse of 32 over 40. Alright. Alright, so I got 38.7 degrees. That's how you do it. That's all there is to it. So, heavy reliance on the calculator for these. Now for the special right triangles, there's less of a reliance on calculators. Okay, so if you have any of these special triangles, like 45, 45, 90, or 30, 60, 90, then you can use special numbers, and you don't necessarily have to use a calculator to find cosine, sine, and tangent, and all that stuff, okay, for these types. So if you have a 45, 45, 90, which is this one's clearly the 45, 45, 90 triangle. The sides are given by this, okay? So the sides are given by, so we'll call this, we'll call like one side A, all right? So this is A, and then A times square root of 2. Okay, so in this example, A can be any number, but since these are both 45 degrees, these two sides are actually identical, okay, in length. So we'll call them A. And then to find the hypotenuse, you just take the length of either one of those legs and multiply it by square root of 2. And that's how you get that third side. For the 30, 60, 90 triangle on the right, so the side that is the shortest, which is the side that is beside the 60 degrees. So the side that is beside the 60 degrees is the shortest side. We call that A. Okay? The side that is the second longest, right, which is this side here, the side by the 30 degrees, we call that A times square root of 3. And then the side that is longest, the hypotenuse, is twice the length of this side. So if we know that this side is 1, then the hypotenuse is 2. Okay? And if you think about it, if you do the Pythagorean theorem, this makes sense, right? So if you did the Pythagorean theorem, you got a squared plus a root 3 squared equals 2a squared. Then this makes sense because you got a squared plus square root of 3 squared is 3, so we have 3a squared, which is 4a squared, which this matches. See, a squared plus 3a squared is 4a squared. So this checks out. Okay, so this checks out by the Pythagorean theorem for right triangles. All right, so therefore you can use these sides to your advantage. So let's show you how to use that. So, and number one, you have a 45, 45, 90. Okay, we can clearly see that by the angles here. Okay, so that means that this side is identical to this side, so x has to equal 7. Done. And then for y, so it says that the hypotenuse is the side times square root of 2. So that means that y is 7 times square root of 2. Done. No other math necessary. This one's 45, 45, 90, so that means x has to equal y. Alright, but we know the hypotenuse is 8 square root of 2. Okay, so that means that we're going to say that a square root of 2 has to equal 8 square root of 2. Well, that just means that a is 8, right? So a has to be 8. So that means these sides are 8. x equals 8, y equals 8. And that's it. For number 3, another 45, 45, 90. So x has to equal y. And we know the hypotenuse is 6, right? So that means that we're gonna set that 6 equal to the a square root of 2. So that means a square root of 2 has to equal 6. So we got to solve for a because these are both a, right? So that means that we got to divide by square root of 2. So that means a is 6 over square root of 2. But we just said, so a is x and x is y, right? So that means that x is 6 over square root of 2. And so is y. Okay. For number 4, we have a 30, 60, 90 triangle. So that means the side that is shortest, that's my a. Okay, so a equals 5. And if we look at the triangle above, it's the bottom is, or the side that is next to the 30 is a times square root of 3. So that means if a is 5, then x has to be 5 square root of 3 since a is equal to 5. Okay, remember that this side is a square root of 3. So x is 5 square root of 3. And then the hypotenuse is twice a, right? 2a, which in this case is 2 times 5. So y is 10. All right, number 7. So we have another 30, 60, 90 triangle. The side that is closest to the 60, right? This side, the shorter side, is a. This is a times square root of 3, right? So that means that y is 8 square root of 3 times square root of 3. So that's my a. And then we need to times it by another square root of 3 because of this guy. And that's your y right there. So square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3, so 8 times 3 is 24. So y is 24. All right, and then the hypotenuse is 2a, which is double what we have here. So 2 times 8 square root of 3, 2 times 8 is 16. So 16 square root of 3. All right, and then the last one, we have another 30, 60, 90 triangle. So the side closest to the 60 that is shorter is a. So a is just x. This side is a square root of 3. So that has to equal 27. So we got to solve for a. So we got a is 27 over radical 3, which that means that's what x is. And then y is 2a, which is double whatever x is. So x is 27 over radical 3. So 54 over square root of 3. All right. And also, and that's it. So you just have to be able to use trig ratios for that. You have to be able to find the missing angle using the sine, cosine, tangent. Find the missing side using cosine, sine, tangent. And that's about it. So I hope this lesson helped you guys. Those are the lessons. Those are the goals for the lesson. And I will see you guys later.